So in this lesson, we are going to take dimensional analysis or conversions just like one single step further. It's not that much more complicated, but some students tend to get tripped up on it a little bit. So we are looking at learning target 2.5, which is I can use dimensional analysis to solve conversions with rates, and we will go into what that means in a minute. But dimensional analysis in terms of conversion with rates, what that means is that sometimes your unit is going to have a number on the top and the number on the bottom. What technically that is, that's a derived unit. That means that you didn't measure miles over gallons, as the example exists, or as the example suggests, but it's something that you probably had to calculate. So 15.83 miles per 1 gallon, that's kind of what we're looking at here as an example, is pretty close to the gas mileage of my vehicle. So it's not really awesome, but it's still what it is. But what this really means is that if we say something is like 15.83 miles per gallon, it's the number of miles in 1 gallon. Or another way to write it would be like 15.83 miles over 1 gallon. And that really is getting at the idea that these units are really ratios or the relationships. Okay. And so the best way I think to go through and discuss how this works would be to go ahead and do a few example problems. And while I'm getting prepared to do a few example problems, if you haven't done so already, you might want to go ahead and get out your periodic table, which remember I named mine Jethro on the front, and then is Sally, and then we have a Sally over there, and then this on the back is the conversion factors that you don't have to memorize. So pushing along. So here we have a relationship where we're going to convert 125 milligrams per deciliter to grams per liter. So we're looking at the relationship of milligrams per deciliter to grams per liter. And for me, sometimes I need to actually see it. I can't like look at that at those words and understand what it's trying to tell me. So a lot of times I will write out 128 milligrams and put it over 1 deciliter because that helps me see stuff. And then just like we did in the last couple of lessons, we have to set up our conversion factors. So we're going to have a conversion factor between milligrams and grams, right? So what we're going to really be looking at here is the thing that makes them the same or similar. So I see mg and g. So that helps me in terms of keeping things together and keep track of things. Now, you might be saying, well, I'm going to look at my handy dandy conversion sheet over here and try to identify the relationship between milligrams and grams, and you'll see that it's not on there because you're supposed to have memorized it. So if you forgot, it's the relationship is 1 gram is equal to 1,000 milligrams. And then the next relationship or conversion factor that we're going to have to set up is between the other unit in the problem, the other unit in the problem, which in this case, we are going to be comparing deciliters to liters. Okay, so I'm going to be looking at the relationship between liters and deciliters. And if I consult my handy dandy conversion chart, I see that 10 deci is equal to 1 base, right? And so what that tells me is that 10 deciliters are the same volume as 1 liter. So now I have the conversion factors or relationships that I need, and I'm going to go ahead and set up my dimensional analysis problem so that the units cancel out. And so the first thing I'm going to do is I usually personally start with the unit on top, just because it's how my head works. So if I have milligrams on top and I want to get rid of the unit of milligrams, just like before, I would put milligrams on the bottom, and then I would put the unit I'm trying to find, which in this case is liters, on the top. And nope, not liters, I lied, grams. And then I'm going to fill in my values that I've just already figured out. So 1 gram is equal to 1,000 milligrams. Now, if I just look at the units that I have here, milligrams cancels out. Now, don't write this part down because I just kind of want to say this part out loud. If I do the math right now and get my answer, right, my answer's unit would be grams over deciliters because I haven't done anything with deciliters yet. Does that make sense? So I am going to continue this problem, and I want to get rid of deciliters, and I'm going to put deciliters on top this time, okay? And then I'm going to put the unit of liters, which is what I'm trying to find, on the bottom. And this can be confusing for some students because some students usually think about, like, when I'm trying to convert something, I always try to put it on the bottom and try to cancel it out. But like in reality, we need to have one thing on the bottom and one thing on the top in order for it to cancel out. So in this case here, I have 1 liter and the relationship is 10 deciliters. And if I go back and I check my units, deciliters cancels out. And now when I go and I do my math, I see that my final unit will be grams over liters. But we're going to do the math now, and so we're going to take 128 times 10, which gives me 1,280 over 1,000. And so now I'm going to simplify that, and I'm going to get something like 1.28, and now my unit will be grams over liters. So my unit will be grams over liters. Questions about this? All right, so the next problem is a little bit more complicated, but it's the same idea. So we're going to be comparing 58 miles per hour to kilometers per second. Okay. And so again, I usually write things out because I can't see it in my head otherwise. So I'm going to take 58 miles and put it over 1 hour. And then I'm going to try to set up my conversion factor. And the first thing I'm going to be comparing is miles and kilometers. And so I'm going to consult my my conversion sheet, and when I'm consulting my conversion sheet, what I'm seeing is that the relationship between miles and kilometers is right there in front of me. So I'm going to set up my conversion factor. So the relationship says 1 mile is equal to 1.609 kilometers, and that's what the relationship is that we were told. The next thing that we are going to be looking at is the relationship between hours and seconds. And I don't know about you, but like I don't have enough headspace to keep all these things track inside my head. So I know that I'm probably going to have to do a step or two here. So I'm going to look at hours and I'm going to try to get to seconds. And so what's a way to get from hours to seconds if I don't know the relationship directly? Many of you are screaming outside inside your head, go hours to minutes, and then go minutes to seconds, right? So in this instance, we know that 1 hour, according to our handy-dandy conversion chart, 1 hour is equal to 60 minutes. And we know that 1 minute is equal to 60 seconds. Again, according to our handy-dandy conversion chart, or just general knowledge that you happen to know. And so just like we did the problem before, I'm going to set this up and take care of the mile portion, or the part on top, first. And so when I set this up, I want to make sure that miles cancels out. So I'm going to put the unit of miles on the bottom, and I'm going to put the unit of kilometers on top. And then I'm going to fill in my values. So the 1.609er is equal to 1. And at this point, if I check to see if I can cancel anything out, my unit of miles cancels out, And at this point, my answer would be kilometers over hours. And that is a unit, but it's not the unit that we're looking for. So I'm going to continue. And we're going to go hours to minutes. And when we go hours to minutes, I need to get rid of hours. So I'm going to put hours on the top. And I'm going to put minutes on the bottom. And our relationship is 60 minutes. So the question is, do we have to cancel out kilometers? And the answer is, in this problem, we are looking for kilometers to be on the top. Okay. When we're done. So that's why I didn't cancel out kilometers. Okay. And then, so if I go to check though what I can cancel out at this point, I can cancel out hours, right? And my unit at this point would be kilometers over minutes. And although that is an appropriate unit, that's not the one we're looking for. So we're going to continue. So now I'm going to use my relationship where I want to get rid of minutes. So I'm going to put minutes on top. And I'm going to put seconds on the bottom. And we know that 60 seconds is equal to 1 minute. And then I'm going to look and see if I can cancel anything out. And I see that minutes cancels out. So now I'm left with a unit that will be kilometers per second, which is what I want. So I'm going to simplify or multiply straight across, which is 58 times 1.609. And I'm going to get a relation, or I'm going to get like 93.322. And then 60 times 60 is 3,600. And then I'm going to go and simplify that. And when I simplify that, I get something like 0.026. And this will be kilometers in 1 second. So does that make a little bit of sense so far? So there's one more problem. This one I want you to try. Okay. It's the 14 miles per gallon to kilometers per liter. So I'm going to give you an opportunity to try that right now. All right, so wandering around, it looked like a lot of you are on the right track for this, which is great. So we needed to first of all find the relationship between miles and kilometers, and we also need to find the relationship between gallons and liters. And so when I set this up, my problem, miles canceled out and gallons canceled out, and I was left with kilometers over liters, which is what I was trying to find, which in this case, I got something like 5.95 kilometers over 1 liter. Any questions about this? Excellent.